Hello, and thank you to everyone joining us. My name is Vicky, and I'll be your Webinar Hub host for today. I'm excited to introduce our webinar for today titled Rock Fluid Interaction Lab, Informational Lunch and Learn. Now, webinars are interactive and they work best when you're involved. So if you have any questions or comments at any time during the presentation, use your questions chat box in the control panel on the right-hand side of your screen, and we'll try to attend to your questions during that Q&A session. We'll be covering a lot of useful content today, so this presentation is being recorded and we'll make that available for you to stream after the live webinar. And before we get started, I would like to thank Cangia, who's making today's webinar possible. The Canadian Geothermal Energy Association is the collective voice of Canada's geothermal industry, with a focus on power generation from geothermal energy resources and industry-scale direct use. Cangia supports their members by providing industry information, hosting events with member discounts, organizing market visits across the world, and more. In turn, membership fees directly support their efforts to unlock Canada's tremendous geothermal energy potential. As well, they assist decision makers at the community level and in the corporate, public, Indigenous nations, and nonprofit sectors to uncover new sources of value in their rapidly changing societies. Cangia organizes events to provide education and outreach opportunities for Canadians. They encourage you to reach out to info@cangia.ca if you would like to learn more about the benefits of a Cangia membership and how you can enter the Canadian geothermal energy industry. Now, I'm happy to introduce your speaker for today, Dr. Jonathan Banks. Jonathan is a hydrogeologist and geochemist with over 10 years experience in the geothermal energy sciences. He came to the University of Alberta in 2013 after working for several years as an experimental geothermal power plant north of Berlin, Germany. A staff member in Earth and Atmospheric Sciences, Jonathan is currently leading the university's geothermal energy team and is responsible for coordinating interdepartmental and intercollegiate geothermal research activities. He brings an entrepreneurial spirit to the laboratory with a focus on building bridges between pure science to applied science to commercial success. Jonathan is a pioneer in advancing several transformational technologies for Western Canada, including the use of supercritical CO2 as a thermal energy transport fluid in crystalline rocks and the development of a novel ultra-low temperature differential heat engine. Through the ongoing deep dive analysis in partnership with Alberta Innovates, Energy and Environment Solutions, and several regional municipalities, Jonathan is also the leading figure in commercialization focused on geothermal energy exploration and development in Alberta. And now it's my pleasure to hand the mic over to you, Jonathan. You may begin when ready.
Good morning, everybody. I've just got a little video here prepared to start things off, and then we'll get into the presentation after that.
Hello, my name is Jonathan Banks. I'm the director of the University of Alberta's Future Energy Systems Geothermal Research Program. Today, I would like to introduce you to our Fluid Rock Interaction Laboratory, which is a full-service laboratory that can do analytical geochemistry, experimental geochemistry, and geochemical modeling of geothermal systems. Over the course of this video, we are going to introduce you to a few of the machines that we have here in the laboratory, what their uses are in geothermal development, how do we make take advantage of our facilities. Thank you very much. Hello.
Yeah, so just to give you a quick tour of some of the machines that we have, on the viewer's left here, we have a machine called a helium pycnometer. This is a machine that can measure the porosity of a rock by measuring the skeletal density of the solid material in the rock. So if you know the volume of a sample that you have and the mass of the sample that you have, this machine can tell you what the porosity or what the pore volume of the machine is, of what the rock sample is. Once you know the porosity of the rock, you can also measure the permeability of the rock. The picture that you see on the right here is a machine called a nano-Darcy permeameter. This can measure rock permeabilities down to 10 to the minus 23, which is a nano-Darcy scale. It can also measure up to 10 to the minus 12, which is tens of Darcys. I'm sorry, tens of millidarcies. So the machine is highly sensitive. It can cover quite a broad range of permeabilities, which means it's useful for measuring permeabilities in a broad variety of rock types. Both of these machines are used to characterize the physical and hydrogeological properties of the rocks. And these machines are designed to start to move that into physical and chemical analysis. On the right, we have a machine called a gas sorptrometer. This can also confirm the measurements of the porosity, but can also give us information about the nature of the pore spaces themselves, how interconnected the pore spaces are, what the shape of the pore spaces are they flat planes, are they big bubbles? And all of this gives us very important information about how fluid will move through a reservoir. The machine on the right here is a stirred tank batch reactor. This is designed for doing geochemical risk experiments under hydrothermal conditions. This machine is made out of a metal alloy called hastelloy. You can boil hydrofluoric acid in it, so it's highly resistant to corrosion, and it can operate at up to 500 bars of pressure and 300 degrees Celsius. So in this machine, we can do experiments based on the chemical reactivity of the reservoir itself. This is very important for production and injection testing, production and injection testing, as well as reducing the risk of induced seismicity. And it can also do scaling and corrosion testing, which reduces the risks of mineral fouling in the surface plant. We're able to do a variety of different kinetic and equilibrium mineral solubility experiments in this reactor. Moving along, we also have some analytical equipment. On the right is our mass spectrometer. The University of Alberta are leading experts in measuring cations and anions in highly saline brines. So we're able to do much more comprehensive and accurate measurements, especially in dense fluids. A lot of labs specialize in measuring the chemistry of fairly fresh waters. Our lab specializes in measuring the chemistry of salty waters, so sodium chlorine brines, calcium chlorine brines, and also sulfate bearing and carbonate bearing brines. The machine on the right here is a thermal conductimeter. It can measure both thermal conductivity and the heat capacity of a fluid or a rock. And these are essential ingredients to incorporate into geothermal reservoir models for predicting the rate of heat production, the lifespan of the project, of a potential project, and how fast you may get thermal breakthrough between production and injection wells. Putting all of this information together, we also have fairly robust facility for doing various types of geochemical and exploration type modeling. For example, we've done a lot of regional modeling of reservoirs in the Alberta foothills. We're also able to do reservoir modeling on much more detailed or localized levels if there's a specific reservoir in mind that you have. We do reactive transport modeling, which can show the evolution of the thermal and chemical state of a reservoir over time. This is a, what is this? This is a 30-year simulation, it looks like, maybe 25-year simulation of the thermal evolution of a reservoir that's producing heat. So you can see we got thermal breakthrough here after 25 years. We do power production forecasts. That's what this Monte Carlo chart is, the bar graph. And then we can also do geochemical risk type modeling to let you know what types of minerals may precipitate in your geothermal system, where, and what the best ways to manage those risks are. So that's a very brief interview into our laboratory, the analytical equipment we have, and then what we do with that information to make sense of geothermal projects. And with that all being said, I'm happy to take any of your questions.
Well, thank you very much for that insightful presentation. And now I would like to invite our audience to continue sending in their questions or comments right now using the questions window for the Q&A portion of this webinar. And I've already received some questions, so I'll go ahead and get started with those. And the first question we have here is, how much do these services cost?
There's a range, and a lot of it depends on the nature of the sample that you give us. So if you give us a raw sample, you know, you just pulled something out of a well, or you pulled something out of an outcrop on a field, that's analogous to your well, and we have to do all of the preparation for it. For the porosity and the permeameter and the gas spectrometer, we're looking at $200 to $300 a sample. If you're able to prepare the sample for us and give it to us, we're looking at more to the $75 to $100 range for those types of measurements. For the experimental stuff, we would work with you together to design the experiment, and then it depends on how long the experiment would run. Sometimes with these kinetic experiments, they can take a week or more, in which case we might be looking at $1,000. If it's a quick experiment, again, we're looking at in the couple $100 range per experiment, and that also includes all of the analysis of the results. So we won't just give you a spreadsheet with your results, we'll also give you some paragraphs that explain what this means in the context of whatever it is you're trying to do.
Perfect. Thanks for that informative answer. And the next question here is, what is the typical timeline for analyses to be finished?
Some of that depends on the time of year. So right now in the summer, we don't have a lot of students around, and so there's relatively easy access to the machines. Some of the machines are in higher demand than others, so we only have the one reactor. So again, when it gets into experimental stuff like that, we would need to talk about timelines and goals and see where we can fit you into the schedule. The other machines, the porosimeter and the gas spectrometer, the thermal conductimeter, and the mass spectrometer, these are all pretty quick. Usually we can get results back to people within a week, if not a couple days. The permeameter also depends. We only have one of them, and it can take a while to do the measurement. So it really depends on where you are in the queue. Once your sample's up, usually it takes about a day to run a sample in the permeameter correctly.
Perfect. Thanks for that answer. And the next question here is, are the results confidential?
That's up to you. So we, we can enter into agreement where you're saying we're providing these lab services for you, but we do not own the data afterwards, in which case it is confidential and we're not free to publish the data, and it's for you to do with as you please. We can also enter into research service agreements in which we do have the rights to publish some of the data in certain contexts, and that usually comes with a substantial discount to the client.
All right, perfect. And this brings us to our final question for today's session. And that question is, are there opportunities for broader partnerships with the University of Alberta?
Yeah, there are always partnerships for opportunities for broader partnerships with the University of Alberta. We usually work in partnership with Alberta Innovates here locally if the project is in Alberta, and we also work together with NSERC for projects on a federal level or up in the territories. And the way that works is that we are usually able to provide companies that want to enter into a broader agreement with us with matching funding for their cash. So that usually looks like a company paying in advance for a bunch of services or paying in advance for a student, and then we're able to match that dollar for dollar. So we're able to increase the capacity of what we're able to deliver to the company. And those are usually focused on specific projects. So a company has a reservoir in mind, and they need some assistance with some of the more foundational and applied scientific aspects of the development rather than the engineering and the economics. They may come to us for some foundational level support along those lines. And there's a number of different programs through NSERC and Alberta Innovates that we have access to.
Great. Well, thank you very much for those answers. We have reached the end of the Q&A portion for this webinar. If you do have any further questions, please direct them to the contact information showing on your screen. And here we have an email that is jbanks@ualberta.ca, or feel free to visit www.geothermics.ca. And thank you everyone for participating in today's conference. A survey window will be popping up on your screen, and we'd appreciate your participation as it will help to improve our future webinars. And once again, please join us in thanking our speaker, Dr. Jonathan Banks, and we hope you found this conference informative. Have a great day, everyone.